What's up, space mystery fans? Today, we're diving deep into the heart of our planet to uncover the explosive secrets of how volcanoes are created. Get ready to see molten lava, powerful eruptions, and the mind-blowing science behind these natural wonders. Let's get started. How are volcanoes created? Journey from Earth's interior to the surface. Volcanoes are mysterious and fascinating natural wonders that demonstrate the immense power and continuous dynamism of the Earth. The formation of volcanoes spans millions of years, resulting from complex geological movements and interactions between the Earth's inner layers. To fully understand this process, we must delve into the Earth's geological structure, the movement of tectonic plates, and how magma travels from the Earth's interior to the surface, creating volcanoes. The geological structure of the Earth. The Earth consists of multiple layers, each with distinct properties and functions. From the outside in, the Earth can be divided into four main layers: the crust, the mantle, the outer core, and the inner core. The crust, this is the Earth's outermost layer, ranging in thickness from 5 to 70 kilometers. The crust includes two main types: the oceanic crust, which is thinner but denser, and the continental crust, which is thicker but less dense. The crust contains major components such as silicates and minerals, serving as a protective layer for the deeper layers. The mantle. Situated beneath the crust, the mantle makes up the majority of the Earth's mass, extending to a depth of about 2,900 kilometers. It is divided into the upper mantle and lower mantle, with the upper mantle being ductile, where convection currents occur. These convection currents play a crucial role in transporting heat and materials from the core to the crust. The outer core. The outer core lies beneath the mantle and is believed to contain a liquid alloy of iron and nickel. Extending from about 2,900 kilometers to 5,150 kilometers in depth, it plays a significant role in generating the Earth's magnetic field through the motion of conductive fluid. The inner core. The inner core is the solid part of the core, starting from about 5,150 kilometers deep and reaching the Earth's center at approximately 6,271 kilometers. It is primarily composed of iron and nickel and remains solid due to the extreme pressure, despite the high temperature. The formation of magma. Magma, the primary material responsible for volcanic eruptions, forms from the partial melting of the mantle and lower crust. There are three main mechanisms leading to magma formation: decompression melting, heat-induced melting, and flux melting. When tectonic plates move and diverge, the underlying mantle stretches, causing a sudden decrease in pressure, leading to the melting of mantle material. This is the primary mechanism that creates magma at divergent plate boundaries, such as mid-ocean ridges. Magma can also form when the temperature rises high enough to exceed the melting point of rocks. Temperature increases may occur due to the movement of magma from hotter areas to cooler mantle regions, or due to the volatilization of fluids within minerals, lowering the melting point of rocks. The addition of volatiles like water and gases from tectonic processes or the breakdown of minerals can lower the melting point of rocks, leading to magma formation. This typically occurs at convergent boundaries, where oceanic plates subduct beneath continental plates, bringing water and other materials into the mantle. The movement of magma. After formation, magma begins its journey from the mantle or lower crust to the surface. This process involves several complex steps influenced by various factors such as pressure, temperature, and magma composition. As magma rises, it can accumulate in reservoirs or magma chambers beneath the crust. Magma chambers act as storage, where magma can reside, stratify, and change composition due to processes like fractional crystallization and mixing. Magma from the chambers can find its way through fractures and faults in the crust, forming vertical intrusions, dikes, or horizontal intrusions, sills. These conduits allow magma to move upwards through the crustal layers. Ultimately, magma finds its path to the surface through conduits, which are narrow pathways leading from the magma chamber to the volcano's vent. The pressure in the magma chamber and the decrease in pressure as magma ascends contribute to the strong forces driving magma to erupt. The eruption process of volcanoes is the final result of pressure accumulation and energy release as magma reaches the Earth's surface. Eruptions can occur in various forms, from gentle effusions of liquid lava to violent explosions. These eruptions happen when low-viscosity lava flows out from the volcano's vent, spreading to form long, slow-moving lava flows. This type of eruption typically occurs at shield volcanoes, creating volcanic landscapes with low slopes and wide areas. Explosive eruptions occur when high-viscosity lava cannot flow easily and becomes trapped in the conduit, causing pressure buildup. When the pressure becomes high enough, it can result in powerful explosions, ejecting pyroclastic fragments, ash, and hot gases with great force. Stratovolcanoes are commonly associated with this type of eruption. Pyroclastic eruptions. These eruptions generate pyroclastic flows, which are mixtures of solid or semi-solid fragments and expanding gases, moving rapidly down the volcano's slopes. Pyroclastic flows can cause severe damage to surrounding areas due to their high temperature and speed. When volcanoes erupt underwater, lava may come into contact with seawater, leading to the formation of unique volcanic structures, such as ash columns or submarine lava flows. Submarine eruptions typically occur at mid-ocean ridges or underwater hotspots. Phenomena associated with volcanic eruptions. Volcanic eruptions not only produce lava flows and ash, but can also trigger various other phenomena such as tsunamis, mud flows, and geomorphological changes in the surrounding areas. Submarine volcanic eruptions or landslides caused by volcanic activity can trigger tsunamis, leading to large waves and devastation along coastlines. Volcanic tsunamis are less common than those caused by earthquakes, but can still cause significant damage when they occur. When volcanic ash and debris mix with rainwater or melting ice, they can form lahars, which are fast-moving, powerful mud flows. Lahars can bury settlements, causing significant property damage and loss of life. Volcanic eruptions can alter the terrain around the eruption site by creating new craters, destroying existing landforms, or accumulating layers of lava and ash. These changes can affect river flow and the distribution of local ecosystems. Types of volcanoes. Based on shape and eruption style, volcanoes are classified into various types, each with distinct characteristics and behavior. Shield volcanoes. Named for their broad, shield-like shape, shield volcanoes have gentle slopes and are primarily formed from fluid basaltic lava. Eruptions of shield volcanoes are usually non-explosive, producing long, slow-moving lava flows. Stratovolcanoes. Also known as composite volcanoes, they have a conical shape with layers of lava and pyroclastic materials stacked upon each other. Stratovolcanoes often have explosive eruptions that can cause severe damage due to ash and pyroclastic flows. Cinder cone volcanoes. These small volcanoes are built from volcanic debris, cinder, and have steep slopes. Eruptions of cinder cone volcanoes are usually short but intense, creating layers of sand and ash around the crater. Lava domes. Formed from high-viscosity lava, lava domes have a nearly flat structure and tend to expand as lava continues to push up from beneath. Eruptions of lava domes are often non-explosive but can cause pyroclastic flows if pressure accumulates. The development of volcanoes over time. Volcanoes do not remain active continuously. They undergo phases of development and transformation over millions of years. These stages may include initial growth phase. When a new volcano starts to form, it experiences small eruptions, building the basic structures of the volcano. This phase often includes cinder cones or other small formations. Active phase. During this phase, volcanoes undergo vigorous and frequent eruptions, increasing in size and changing structure. Shield volcanoes and stratovolcanoes often grow significantly during this phase. Dormant phase. Volcanoes may stop erupting for long periods but retain the potential to become active again. In this phase, volcanoes can accumulate pressure and prepare for future eruptions. Extinct phase. A volcano is considered extinct when it can no longer erupt due to the cooling of the magma chamber or other geological changes. These volcanoes no longer pose a threat, but may still be significant geological landmarks. Volcanoes are not only sources of geological phenomena, but also play crucial roles in global ecosystems and climate. Volcanic eruptions can impact the climate by emitting sulfur dioxide, SO2, and fine particles into the atmosphere, creating layers that reduce sunlight reaching the Earth and causing global cooling. Additionally, volcanic lava and ash can create fertile soil, rich in minerals, promoting the growth of flora and fauna. Areas around volcanoes often have diverse and thriving ecosystems that develop vigorously after eruptions. The formation of volcanoes is a vital part of the Earth's geological system, demonstrating nature's dynamism and power. From the processes forming magma deep within the Earth, the complex journey to the surface, to the intense eruptions, volcanoes represent a complex and awe-inspiring journey. Studying volcanoes not only helps us understand the Earth's structure and activity, but also provides valuable information to predict and mitigate volcanic hazards, protecting lives and property. Active volcanoes are not only threats, but also symbols of the Earth's continuous creativity and transformation, reminding us of the complexity and beauty of the natural world.
That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.